All right. Okay. Hi, everyone. It's actually great to be here. This is actually my first time at iOS conference in general, so really excited to be here. And just thank you again for inviting me. So so today my talk will be about color maps, accessibility, as well as UI styles. There's going to be a lot of colors. I hope it doesn't blind you, but hope it's interesting. All right. Okay, so maybe before I start, I'll just give a little bit of a background about myself. So I'm originally from the U.S. I was born in the USA, and I moved. I actually started traveling quite a bit, and then right around 2010, I moved to France. And it was in France where I did my doctorate studies. And then in 2015, I moved to Singapore, and I've been there ever since. So yeah, it's been quite a while in Singapore. Definitely feels like home. My background is actually in quite a few different areas. So I was originally an electrical and computer engineer. I also studied mathematics as well. So that's what I was doing mainly in the US, as well as France. So lots of different areas in radar, antennas, numerical techniques, all sorts of things. When I moved to Singapore, I started working for ST Electronics in the area of SATCOM. That was really, really exciting. I got to play with some really, really super cool hardware. And then when I joined Rolls-Royce, I joined as a decision scientist. So a decision scientist, the name is interesting. It sounds like data scientist, but it's a little bit different. Pretty much my job was to, help take those, analytics outputs or those data science outputs and convert them to a form that, users can understand and that they can consume. And it's actually because of that I transitioned over time to become a UX lead, UX UI lead, because it really just helped me get that job done in terms of decision science. In terms of my relationship with iOS, so it was actually during this transition that I discovered Swift. It was completely on accident. I was actually prototyping with it. I really was just playing around. This was probably literally less than 5 years ago, so not that long ago, and I just really liked the language. I was like, wow, this is really cool. It had probably been years and years since I had really done any coding. I was more into the numerical techniques, but I just really enjoyed it. So I started, I just kept using it. I was using it for prototyping, and then of course, when the pandemic came, being locked up inside, there just wasn't really a lot to do. I just really dove quite deep into it. So I started learning, all sorts of things. I was learning UIKit initially, doing all the training. Although I admit I got a little bit scared away when I was learning authentication and authorization. So I was learning how to do it natively. I think it took about 2 months. It was during the pandemic, and at that point I thought, oh wow, okay, I'm just gonna eventually start using it for design again. But I was just really, really enjoying it, and at some point I switched over to Swift UI and got super, super confused. I was very lost. I was literally fighting with everything. I thought, oh wow, I spent all this time learning Swift, and now I feel like I'm starting over from scratch. But I mean, it was okay. I think it was just a matter of rewiring my brain a bit. It was just a different way of thinking. So I still use Swift UI. I love using it for design. I actually don't know how many designers are using Swift UI, but if there aren't that many, I hope that many more will, because it's just really, really great. So, all right. Okay, so the agenda of my talk covers quite a few topics, actually 3 topics. So I'm going to start talking about color maps. Then I'll go a little bit into accessibility, a little bit into kind of some data visualization, and then finally I'll go into UI styles. So These are all, they're actually really, really big topics. Each one of them, they're huge. In fact, when it comes to design, there are some designers who just specialize in color. So I won't be able to cover everything. It'll just be kind of a small sample of each of the topics. But yeah, I hope it's interesting. Okay, so yeah, I'll start off with color maps, and hope I'm not blocking the slides. I'll just try to walk a little bit, get some exercise. Color itself is a very powerful visual channel. Color, I guess in the context of visualizing data, it's very helpful. It helps us to, for instance, identify patterns in data, or it helps us to, take data and sort it into different categories. And it also helps us place emphasis on maybe parts of data that we think are more important. So it's one really, really great thing about color. It's actually thanks to color we can do things like, if you imagine you have a two-dimensional matrix that has hundreds, if not thousands of numbers, decimal numbers, for most normal human beings, it's not very straightforward to just be able to look at that and interpret it. But if you convert that to a heat map, you can more easily see patterns. So it's one of the really exciting things about color. Okay, so to get more specific, just to talk about color maps or scientific color maps. So what is a color map? A color map is really, it's an array of colors. That's really what it is. When you kind of view a color map, it will look like a gradient. It gradually changes, but it's really a discrete array of different color values, so RGB values, hex values, and really what you can do with a color map is for any given data set, you can take the numbers out of that data set and directly map each number to a value on that color map that you have. So that's the really great thing about color maps. Color maps are usually designed in a way to help us understand that particular data set much better. So there's a lot of care put into how the color map is designed. So for example, just testing, yeah, the pointer works. The first map above, this is a sequential color map. And this is a good color map to use, say, if you have data that's increasing or decreasing, maybe around some, only positive or negative values. What's actually happening here with the color map is the saturation is changing, so it's actually increasing as you move across the color map, but also the lightness is decreasing. So the way you would perceive the data, if as it was changing, it's almost like the color that you perceive is very representative of the change in the data. So it's just really helpful for encoding, numerical data, understanding data. There are also other types of color maps as well. So for instance, there are diverging color maps, which you've probably seen quite a lot. If you have a reference value and then you have values that fall below or fall above and change, you could use a diverging color map. There are also, for instance, cyclic color maps. So if you have data that's repeating itself, data that's periodic, like, for example, the angle, so the phase of your angle, you could use a cyclic color map. And then, of course, you have rainbow color maps. So those are quite well known as well. And I'll go a little bit more in detail, specifically about the rainbow. So I'm sure a lot of you, especially if you've used, like R, Python, D3, or any of these packages, just anything to visualize data, you're probably familiar or have seen different color maps, and you're probably familiar with the default jet color map. So that would be this map that you see up here. This map is very commonly used in science and engineering. So for instance, when you're looking at maybe a fluid dynamics chart, or you're looking at a radiation pattern, they very often will use this jet color map. And with the jet color map, pretty much how it works is usually blue would represent values of lower intensity, the lowest value, and then red would be the value of the highest intensity. So that's typically how it works, and you could say it's a fairly intuitive way of looking at your data. Although this color map, it does have some disadvantages to it. So what's actually happening is, even as you're feels like you're moving across the rainbow, the lightness actually starts to reverse itself, especially as you're crossing the yellow. It's like you're getting lighter, but then you're getting less light. So it's actually not really always the best color map to use. It depends on the situation. And there are people who realize this, actually, quite a lot of people. Two examples are Stefan and Nathaniel. They realize that. This type of color map, it's not the most accessible color map, so people who have issues with color vision would maybe have difficulty in being able to interpret the data as well. Also, if you were to print out some data in black and white, so if your printer didn't have color ink, it could also be a little bit difficult to understand what's going on. Some other things that will actually happen is if you were to look at an image using this kind of color map, you actually might find artifacts appearing that actually aren't really important, that don't really exist, or that they're not significant. So you could end up having some corrupted data, as in the way you're interpreting the data or the way you're encoding the data. There's a little bit of corruption there. And at the same time, you can also lose some details that are important. So data loss is also a challenge that can happen with this color map. But nevertheless, it's a lovely color map. I mean, it has done its job, definitely, I would say, in science and engineering. Maybe another thing, although I know it's probably a little bit subjective, is the aesthetics. There were a lot of people who just thought in general, hey, we can do better. We can make these color maps better, because when it comes to visualizations, especially when you're showing people lots of dashboards and charts, you do want it to be compelling. You want it to really pop out and kind of hit people between the eyes. So Stefan and Nathaniel, as well as some other people, they went on some very long journeys to actually design color maps, different types of color maps that you probably see today when you use R or Python. And these are what we call perceptually, it's a mouthful, perceptually uniform sequential color maps. I'm not going to give like a formal definition. I just kind of made up my own definition. I don't know if it's like the best one, but just imagine what that really means is if I were to give you some candies, I was just to set them in front of you and then ask you, can you just put these in order? You would be able to put them in order all by yourself. I wouldn't need to give you a guide or a legend. You would just know how to do it because of the way the colors are designed. So that's my, I guess you could say my oversimplified definition. But what's happening is you can see, if you look, this is what the color map looks like. This one's Viridis, so it actually matches with this figure that you see here. And yeah, they're just really, really great color maps to use. So let me keep going because I too much time on that slide. So now I'm going to start going a little bit into accessibility, I guess the topic of accessibility. For me, usually when I think about accessibility, I think of it more as when you're creating like a visual or a infographic or anything, just being mindful of how do different people view this? How do people who come from different backgrounds or different perspectives or people under different constraints, are they able to interpret my visualization? Do they understand it? Is it delightful for them? So that's kind of one of the ways that I like to think about accessibility. So maybe going back a little bit more to these color maps, I actually just want to show here just how well they perform, especially under colorblind conditions. When looking at these color maps, so these two charts were produced in RStudio. You can actually directly access the map and create these charts. Sometimes, at least for me at one point, it was almost tempting to think, oh, okay, well, to make this particular color map, it's almost like you just took half of the rainbow. Like you started from yellow and then kind of moved that way, and that's your color map. But actually, there's a lot more that really went into creating these. It was really quite a lot of work, and you can almost see that here. So what I'm showing is, we have the rainbow, the typical rainbow: red, orange, yellow, green, blue. That's how it appears with normal vision, and then if we look at how it appears under different colorblind conditions, we can actually see that you lose a lot of the information, a lot of the details are lost. So for instance, for deuter anomaly, you can see how the blue and the purple, they really start to blend together too much. So if the color map really was just half the rainbow, it actually wouldn't really perform very well, as you can see. And then with deuteranopia, you can see that you lose a lot more. You start to get the brownish yellow and beige for your greens, and same for other types of color blindness. So these color maps, what you see on the right, these are two screens. It actually shows how well and how nicely these do perform under different conditions of color blindness. And apologies, I actually didn't give a definition of color blindness. Sorry about that. But as we know, the ability to interpret color varies across people, and color blindness or color vision deficiency is a situation where somebody just might have difficulty identifying or distinguishing between different colors due to the photoreceptor cells. So this is something that is extremely important when you are using color for data visualization, and it's something that's really, really good to check when you are making charts. What you see here on the right is actually, so as you see, it's on an iPhone screen. I'll talk a little bit about that later. It's an app that I'm working on that I hope to build later this year that'll actually help people to be able to analyze much better the color palettes they're creating. So if you do want to use color maps in your dashboards or your infographics or anything, you could actually use this app to go ahead and analyze different things and to know how well it would perform. Okay, so maybe touch a little bit on the data visualization. So I was kind of saying before, I guess speaking about color, how color is, afraid I'm gonna fall down the stairs. I'll just stay away from that. So I was speaking about how color, again, it is a very powerful visual channel, but it's also one out of quite a few different visual channels. So if we think about a data visualization, we can actually break it down into our marks and our channels, where the marks are those, just the individual elements, the geometric elements like the lines or the bars that actually make up our chart, and then the channel is actually modifying the appearance of that mark. And when creating a visualization, it is important to select the channel that is going to be the most effective for the type of data that you actually want to visualize. And this is really interesting because you'll start to see some differences in how color plays a role in both types of data. So for instance, when you're creating a visualization with data that's going to be ordered, there are actually a certain number of visual channels that would actually be the most effective for ordered data. So ordered data is data that would, be ordered in a sequence, as opposed to data that can be divided into categories that actually doesn't have an order. There's actually a different set of channels that are effective for, categorical data. And these different channels that you can use to either represent your order or your category, they can actually be ranked by how effective they are. And color, just the word color is very, very general. So color actually contains a lot of things. Color contains hue. So if you think about the color wheel that you see in art class, you can think of the hue as, where is it falling on that color wheel? But also there are things like, saturation and brightness and whatnot. And what's happening, or what you can maybe see here, is for categorical data, the color hue is playing a big part. It's actually a very effective channel to communicate your categorical data, whereas if data is going to be ordered, if it falls in a particular order, that's when your lightness and your saturation actually start to play a role. So this is where it gets really interesting, sometimes really, really complicated, but this starts to bring us to, I guess you could say, expressiveness. When you're creating a visualization, you do want to be careful of what message you're getting across, what you're actually showing. What you don't want to do, or maybe what you want to avoid, is conveying something that actually doesn't exist in the data, or having something in the data that you're going to miss. So, for example, if you have a line chart, a line that's moving, but that each point on the line is a different category, you're representing categorical data with the line chart, which actually would make it look like you're seeing a trend. So if you imagine different points, fruit, apple, oranges, and you're showing a trend line, that could be a little bit misleading. So that's maybe something to take into consideration, especially if you're using a color map that's sequential, where a person is going to be tempted to take that color map, or those colors that they see, and they're going to try to put in order to them. So that's just something to consider. If you think of on the first slide when I was showing the different candies, you just want to make sure that you intend for the data to be ordered in that way. If you do, it's actually fine. It's definitely not an issue at all. Okay. Okay, and then the third accessibility topic, just to touch on, is contrast. So everyone knows about contrast. It's the difference in the perceived color. Contrast is something, at least from my experience, when using these different color maps, this really became an issue when I started doing things like adding text, adding annotations, and using icons. So a lot of times when you have a visualization or a chart, it's not just going to be those marks that you're actually showing, not just bars. You might start adding numbers. You might want to add some, icons to either convey a message or just make it more aesthetically pleasing. But when you do this, it maybe is important to be mindful of the contrast. And this actually can be a big thing, a big issue for color maps like these, because if you actually look, the yellow, as we know, yellow against a white background, you really do need to be careful. It's not the most accessible. So, if you had this color map on a white background, depending on how you're using it, if you were using it for, if you're making annotations versus making a bar chart, is maybe just something to be a bit careful about. But then if you just try to flip it the opposite and then just use a dark background, you're going to have an issue on the other side. So you're on a dark background, this dark purple then is not, it's not going to be so easy to see. So I, just in the past when I use these color maps, but again, it would depend on what I'm using them for, how I'm using them, I actually found that sometimes I would make some adjustments to the color map due to these accessibility issues. So for instance, if you take one of the colors and then you look at a test color, you can see if you were to use that color in the foreground, this yellow, it's not so accessible, it's difficult to read. It's also the same if the yellow was in the background and you were trying to annotate something like this, you'd also have some difficulty. And when you are checking contrast, it's actually good to also take into consideration, is this in the foreground or is this in the background? So this is something that is quite important. And what I actually wanted to do, so you're also seeing some Figma screens as well, as when I was using these colors for other things, like, for example, infographics or other things, I was actually taking the RGB codes or the hex codes and copying them and pasting them into another app or another tab just to check, is this one okay? Is this one okay? It got like a little bit repetitive, and I actually thought, well, it would actually be great to have like a one-stop app where I could have, and there are some, but a one-stop app where you can actually have your entire color palette, maybe from a color map you've selected, and just check all of the colors at once. So in one screen, you could see, all right, these are all the colors that I want to use. These are the different colors I want to use for, I don't know, my annotations or my backgrounds. This is how well the contrast is going to perform, depending on whether or not my color is in the foreground or the background. So this is a design that I have in mind that I hope would be able to achieve that or accomplish that. So yeah, it's a little bit on color contrast. So all these screens, so again, I've been showing you quite a few Figma screens. I'm losing my voice because I'm thirsty. So this is actually something that I'm hoping to build this year. I thought it would be really fun. I will admit that I was the original use case. My drive to actually build what I'm going to call maybe a color map generator or a color map palette generator was really just from me. I really loved using these color maps so much. I just really loved generating palettes with them, and I was using them for all sorts of things like infographics, and just the fact that I was spending so much time opening so many different tabs because I was adjusting the colors for my particular visualization. I thought, well, I just love to be able to do this in one app. So that's really where this design comes from. What I actually envision, or I plan for the app to do, is really what you could do is you could first just select a color family. So the user would just choose the color map that they want to use. They could then select a number of points. So in that color family, how many points would I like to use? And then it would automatically generate the palette and then show the hex codes or say the RGB codes for that palette. And then in addition, and this just also comes from my experience of just, I really like to geek out on colors, so I do all sorts of crazy things. But sometimes I would actually, I would use these color maps, but then I wouldn't actually want to use the entire spectrum of the color map. So for instance, I might decide that I don't want any of the yellow in my visual. I've had to do that a lot of times due to accessibility. I would create something, even like, some bar charts or something, and I would just leave out the yellow because I was just afraid the way it looked, it wasn't accessible enough. Or what I would do is I would actually turn it into kind of like a brown color just to make it make it easier to see. So what you're seeing here is kind of like a color picker where you would actually slide, you'd still select your color family, you'd select the number of points you want, and then you could kind of slide around the spectrum to kind of decide, well, where do you want those points to fall? Where do you want them to be? So that's an idea I have that I hope I can build and share with everyone. I think it would be like really convenient to have. I also think, or at least I hope, it looks like it would be fun to code. I don't know. What do you guys think? I just a little bit of geometry and maths. We could maybe get that going. I hope. We'll see. But some other things that I was doing, and this is again just me geeking out on colors, is I was copying and pasting color codes into all these Excel sheets to share them, either share them with people or just keep them to myself. And again, that was another manual process I was just doing. And I thought, hey, I'd love to have that in an app as well, which there are some apps out there where you can, you generate your color palette and you can copy the codes. But I specifically thought it would be great to have one for these scientific color maps. Like these specific color maps. So that's kind of another feature I want. When I was thinking of this idea, I did want to check, though, if it was feasible. So the color maps that I've been showing you, actually, the data you can actually find online. There's no need for an API. There's just one file. If you go to this link here, you can just download download a single file. I just downloaded it, and then I just modified the syntax a little bit so that I can use it in Swift. So I just used a observable object publish variable, and then I just did a few tests at the moment. One of the things I actually really love doing, in fact, if it was up to me, I'd literally do it for the rest of my life, is I love like switching back and forth between Xcode and Figma. So in Figma, like really getting those wild design ideas, and then popping over to Xcode just for like a bit of a sanity check, like, could that really be done? So I could just did it. It's very simple compared to all the things you do. But yeah, just import the color data, and then I checked, in Xcode, can you generate a gradient? Yes, you can. Does it work in the Swift charts? Yep, they work just fine. And then for me, most importantly, is if a user was to enter a given number of data points, can I just generate just the basic palette for them and show them all of the color codes? So if the user was to enter 1 here, it would just return purple. If they were to enter 2, they would get only purple and yellow. And then if they were to enter 3, it would be purple and then kind of a maybe a color around here and yellow. So it would just generate evenly spaced points. So it was really just a test, just to play around with the Swift logic to make sure that these, color maps would work out. So it's on that. Okay, so yeah, I won't dive too much into this, but I'm happy to. I'll be updating my portfolio and everything on the news. I'm hoping I can finish it by this year. I think it would be a lot of fun. I've done some, so since I was actually the original use case for this, and I know that's something you got to be very careful about. You actually need to see, can other people actually use this? Do they like it? So I did, I made a high fidelity design in Figma and did about 5 usability tests so far. And they actually went really, really well. I was surprised. It's very rare to get 100% everyone's okay with the user flow and everything, but yeah, it went really, really well. So I'm definitely quite excited about that. Okay. And then, yeah, I guess one more point I forgot to mention of just like, who do I envision this being for? This kind of color map palette generator. I really think for almost anybody. This can be for an analyst, a developer, a designer, just anybody who wants to use these palettes. But actually going back, just to note, there is a website you can go to where there's an online generator. It's really, really nice. I'm here all the time. But you can actually just go online to find a generator, enter in your number of points and the color map family that you want, and actually generate these points. So my app, it's really just kind of taking that concept and just bringing it offline, and then just adding some extra convenience features. But it's a really wonderful website. It's really great to use. Okay, so now I'm going to change my talk a little bit, because I want to go a little bit more into some user data, some user test data that I collected. I really love collecting user data, because it just really, I find it really insightful to understand how designs are going. So, okay, all right, great. So, yeah, as you know, there are a lot of different UI design trends. Some of them have come to stay. Some of them have gone, which is fine, because they can always come back. What I just did here is I make demonstrators sometimes where I'll just in a single app shove in all different types of UI design styles, and then I'll feed it with some dummy data, and I like to use that to test different types of flows and different types of layouts. And I was actually curious of just where people, I guess where people stand in terms of how they feel about these different UI styles. So as you're probably familiar with, glass morphism is one popular UI style where you have kind of your cards or your UI elements. They're a bit frosty or translucent, and they're usually over a kind of a textured background or a bright background, so they have kind of this glassy look. This has been popular, I'm noting since 2020, but I think maybe even earlier, it's been quite popular, and it's still popular today. You still see it a lot today. And then we have the neumorphism, where UI elements are kind of protruding out, so it's a bit low contrast, although that can vary. This is a style that I think is maybe lost popularity lately. It's not so popular anymore, but it's definitely quite interesting. So what I actually was keen to do, and maybe just a note to add, I'm probably not doing justice to these design styles because there are things that can be done to improve the accessibility. In fact, Paul has shown some really nice tips of you can actually, when you create this style, you can actually add color to make a neumorphic UI actually look a lot more accessible. So possibly the examples I'm using are quite basic, but I just went ahead and did some preference tests because I just wanted to ask users, I just wanted to see what users like. I just wanted to see what they prefer. And what I really like about preference tests is they're just really fast to set up and they're really quick to run. And the data, it's quantitative data, so it's just, I just really love running them. But maybe before I show some of the results, I'd like to maybe just get your feedback. I'm actually curious from all of you, which of these screens would you actually prefer? The actual context, I don't know if it helps, this is just kind of like a marketplace with different fruits, so there's just different flavors that you see here, but maybe the context isn't hugely important. But if I were to just get like a show of hands, if this is, I'll just call this screen 1, 2, and 3. So 1 is this kind of with the flat UI colors with just a little bit of drop shadow. 2 is the kind of glass morphism, although it's quite neutral. And then we have the neumorphic, number 3. Could I get a show of hands? Who likes number 1 the best? Okay, nice. How about number 2? Okay, cool. And then how about the third one? Oh, interesting. Okay. So I'll show you the data that I've actually collected. Oh, sorry, a bit nervous. I forget I have the pointer. Okay, so I asked 60 users. Now I don't know if there's a little bit of bias. I actually ran this test. It was the day after. It was like New Year's. No, it wasn't New Year's Day. Maybe it was like a day later. So I don't know. I don't know if the sample size were the people who felt like doing something after their New Year's party. Maybe there's some bias, but these were the results. 60% of the users, so it was 60 users that I asked, and 60% of them actually preferred the first one, 25% the glass, and 15% our neumorphic design. So that was something interesting to see. I have some more data to show as well, and I'll do one more show of hands out of curiosity. Here, what I've done is I've changed the UI quite a bit, and I'm using just a single color. So maybe if we call this 1, 2, and 3, just to get a show of hands, if you look at this UI, so this is lavender flavor, showing different desserts with flavor of lavender. Who thinks screen 1 is the best? Okay, who would prefer screen number 2? Oh, that's interesting. Okay, and then how about screen number 3? Oh, that's very interesting. Okay, so I'll show you. I just love this data. It's fascinating. Yeah, so that's the results are actually much more distributed in terms of what people prefer. So 25% higher amount compared to the previous layout actually liked the third screen. Okay, and what I'm going to do is I'm just going to go through the rest of them. I'll just show you what they were. This was a preference test that I ran on layout. So actually, I was kind of curious. Sometimes I have trouble deciding between whether or not users prefer to see something in a list or they prefer to see cards. Sometimes I always wondered. So for this particular app demonstrator, I also ran a preference test, and the results were interesting. It was actually almost 50-50. Half of the people liked the list versus others the cards. And just to make a note, this really will depend on the app. It's depending on what the user does. So just because I'm showing numbers, it doesn't mean for your designs, you have to go in that direction. It's something that can vary. Okay, I'll show you just a couple more. Ran another test with the 3 UI styles. This one was quite extreme, so 70% of the people actually preferred the first screen, whereas about a quarter liked the glass, and then we have only 6% here for the third, and then a little bit further. So I changed to, it's more of a carousel, sliding carousel layout preference test. Similar results to the previous, which I thought was quite interesting. And then finally, this is the last test, although this might not be a fair test because the icons you see, the items that you see in the UI are related to food. But I just wanted to see how users felt about warm versus cold colors in the preference test, which depends. But it was interesting for this one that 68% of the users preferred the warm colors to the cool. Although something to keep in mind for preference tests is when you're asking does a user like A, B, or C, you don't want to actually change too much in the UI. So there are different flavors showing. So it could be some bias that's there, especially if your users prefer strawberries to mint. So I guess something to keep in mind. And yeah, that's really it. I have some references here, so if you just want more information on color in general or information on these topics, you're welcome to check out these references. It's a very deep topic, very potent. So I really was just giving you a sample, but I hope it was interesting. And yeah, thank you everyone.